Specialized focus for the roles. Suppose you are planning for RTL design engineers, so you should be good with your with the clock domain processing, static timing analysis, and synchronous design, like how you are doing FSMs and all. Or suppose you are going for a design verification, you should be good with your SV and UVM. I mean, you may not, that may not be part of your curriculum, but you have to go extra edge to understand that SV and UVM. And AMBA protocols, AXI, APB, I2C, SPI, these type of protocols. Or some DFT, if you want to become a DFT engineer. So there are different roles actually in VLSI. And in some of you may have design for testability as one of the subject, or maybe some elective subject. So that whole understanding of what is the meaning of scan chain, JTAG, ATPG, you should understand those terminology, how they are using it. That basic theory is required, okay, when you are focusing on DFT related topic. And suppose you are interested in analog design engineer, you should be good with your circuit theory, and then EDC, how the MOSFET works, BJT works. Similarly, the analog electronics, operational amplifiers, similarly A to D converter, D to A converters, PLLs. So all these concepts, control systems, signal systems, because a lot of mathematics is required in the that mathematical understanding is required here. And else, if you are going for a physical design engineer, so in physical design engineer, I mean, you should be good with your basics like VLSI flow, as well as you should be good with your MOSFET, how MOSFET will work. So what is the leakage current, and what is the power dissipation in the MOSFET? The basics should be good.